ठीक है, तो कल हमने जो कंटिन्यूस बैग ऑफ वर्ड्स का मॉडल देखा था वो कुछ इस तरह से चलता है। तो लेट्स से हमारे पास ये स्टेटमेंट है, द रेड टोमेटो। ठीक है, जो कल हमने प्रॉब्लम देखी थी, इट वाज अबाउट कि हमने इस लफ्ज को ब्लैंक कर दिया, तो वी रिमूव दिस वर्ड basically and giving these two words as the input to the network and trying to figure out what the center word is. तो fill in the blank problem ही है, लेकिन there is another problem. इधर तो ये हम कर रहे हैं, this can be solved another way. यानी कि हम ये कह सकते हैं कि the red tomato, और हम क्या करें कि बीच का वर्ड रखें और ये साइड वर्ड्स निकाल दें, right? And then what we are trying to do is removing these words, and given this center word we are trying to figure out its words around in the context. तो यहाँ पे the big difference is that we are using the context words to figure out the center word. In here we are using the center word to figure out its context words. ठीक हो गया? तो yesterday I built this model कि आपके पास एक hidden layer है जिसमें you decide the number of neurons based on how big you want the embedding to be. अगर encoding का size आपको 3 चाहिए, you will have 3 neurons. और इसी तरह अगर आप context में एक word prior दे रहे हैं और एक word बाद का दे रहे हैं, and the size of this input will depend on कि कितने आपके vocabulary में words हैं. Okay? And you fully connect these two layers. Then you have this output layer, again fully connected, जिसके अंदर you are trying to predict के center word क्या था. Once trained, so there is this W जो weights हैं यहाँ से यहाँ पे connect कर रहे हैं, and these weights would contain all the vectors once this model has been trained. ठीक है, तो train होने के बाद क्या करेगा, if you give this model an input, the tomato, it should give you red out here. ये हम चाह रहे हैं. तो fill in the blank model, and this is known as the continuous bag of words model. Continuous bag of words model for generating word vectors, and these word vectors are here. ठीक हो गया? So I'll remove this and move on to a second model which is an alternate to this model. That second model is known as the skip-gram model, and it solves the second problem. Okay, given a center word, it will try to predict the context of that word. Okay. So I'll not go into the details as I've not been going into the details earlier on. So given the center word, and a hidden layer, the size of which will again be जितनी बड़ी embedding आपको चाहिए for the word vectors, and you fully connect these neurons. Then what you're trying to predict is the context. And you fully connect these as well. ठीक हो गया? Again, you'll train this model, this neural network, and you'll get some weights here, some weights here, and some weights here. Or once trained, what will happen is that you will give it red, and what it's trying to predict is the and tomato. फ्रॉम आवर एग्जाम्पल. ठीक है. ट्रेनिंग इस तरह से हुई हुई है कि इफ यू नोट कि दीज आर ट्राइग्राम्स, द रेड टोमेटो इज अ ट्राइग्राम. जितने भी ट्राइग्राम्स हैं आपकी कॉर्पस में, उनको आपने गुजारा है इसमें से बार बार टू ट्रेन इट, एंड देन यू आर ट्यूनिंग दीज वेट्स बेस्ड ऑन दिस बैक प्रोपगेशन. In this case, the vectors of the words will lie here. These are the word vectors. Again, if red belongs to this neuron, यहाँ पे 1 था, in the one hot encoding, the rest of these were all zeros except for this one, which was a 1. So the weight or the vector of red would come out from these weights, W1, W2 and W3. So the word red would eventually, one hot encoding में तो बहुत बड़ा vector था, this word red finally would have this vector. And this is known as the skipgram model for generating word to vector.